Hello everyone, we are going to talk about the beam intensity control for exposure process. First of all, talk about the beam uniformity control. This is the wafer and the light beam to do exposure process to the wafer, and the uniformity. For example, we measure the light intensity for 3 points, one the central, and 1, 2, 3, 4, 5 edge, and 6, 7, 8, 9 the median, 10, 11, 12, 13. For example, for 13 points intensity, got 13 value, and we use the formula. This is the max value, the minimum value, and the value of the mean value. This formula, we got the limit below 3%. This is the uniformity percent calculus. For example, some formula is not but similar, and the uniformity control by the equipment engineer job. Will do the adjustment to the exposure equipment. Next, the intensity meter control. We can control the intensity and the uniformity by equipment engineer to adjust. But the intensity meter control is the same important job. We use the intensity meter just like this. This is the proper, or we say detector, put here to measure the intensity of the beam. It connects to the meter, so this is the meter and the proper to a intensity meter, and the meter measure result will shift due to exposure. If we use it more time, the result will shift according major times. So after some specific period, the probe and the meter sent back to the vendor side to do the adjustment job. So we cannot use the only one intensity meter. Here is the typical intensity meter control table. We have the 5 meter to do the basic control table. The meter A, we'll use it as usual at fab to measure the process unit at fab, and the meter B every 3 days. Use the meter B to compare with meter A. If A result approaching to meter B, A and B is okay, can use it. But one day A and B have big differences between. We use the meter C to compare with meter A and B. If A not equal B, we can use the meter C to verify meter A or meter B which is fail shift. And send the shift meter back to the vendor side to do the adjustment. I usually use the meter B to compare with meter A is enough, but one day the meter B and meter A, there are big differences between them. We use the meter C to do the judge. And the meter D, where is the meter D, is sent back to vendor side to adjustment. So there are always a meter sent to adjust, not at fab side. So we got a meter D, and meter E is spare. Why spare? You can see that meter A, B, C, D, you cannot lack anyone. You have to have enough power to do the control at product fab. So at least I have to got 4 units of the meter to use all the time. So if any something wrong, we have an emergency spare. It's very important. So meter E is a spare to prevent from issue happens. And what issue? The issue often to see that is one meter is broken. Always happen if we use for a long time. We can use a spare to instead of it. Or occasionally we meet an accident. Meter A not equal meter B and also not equal meter C at the same time. It's not usual, occasionally. So we got the meter E to do the verifying at last. Or occasionally we made that we sent meter D to the vendor side to do the adjustment, but adjustment postponed. This accident by the vendor side. You can say nothing about it. So we have a spare. Meter E is very important and necessary to have it. This is at least we have 5 meters for the basic intensity meter control table. At last, we look at it. As my experience, the uniformity percentage, we are happy to see it. The spec is very low, even 1%, but it's not okay for the process window. So, as equipment engineer, we like to adjust the uniformity percentage very low value, but about process window, we cannot just use a very low level uniformity percentage. As an equipment engineer, 1%, 0.5% is better, but the process window, 5%, even 10%, even better. You know what I mean? Even the intensity uniformity shift, the product still have a good yield. That's the process window. Good window has a large spec and large limit. It's the same. The intensity value up or lower, that's okay if process window big enough to do the tolerance of the intensity and the yield. Still good with bad uniformity and a bad shift intensity. Still good. It's a excellent process window. So the process big is better. No necessary to push the uniformity and the intensity control at a very small spec, because that means that your process window is too small to have any mistake. That's all. See you next time.